In this video, we will continue our examination of operations on radical expressions, and we'll focus on the quotient property of radicals. Now, the quotient property of radicals says that if you have the nth root of a fraction, you can split the root across the numerator and the denominator. So if I have the nth root of a over b, it's equal to the nth root of a over the nth root of b. We've applied this concept as well when we were simplifying radicals and simplifying nth roots. And so if I have my first example, I have the square root of 81 over 25. So to simplify this, what I can do is split the square root across the top. So I have the square root of 81 over the square root of 25. And then simplify them separately. Well, the square root of 81 is 9. The square root of 25 is 5. So my answer is 9/5. It's the same over here. I have the square root of 49 x to the 6th over 16. Split it across the fraction. So I have the square root of 49 x to the 6th over the square root of 16. So the square root of 49 is 7. The square root of x to the 6th, 6 divided by 2 is 3. So you have x cubed over the square root of 16, which is 4. And so my answer is 7x cubed over 4. In this video, we're going to continue examining our quotient property of radicals, but we're going to be focusing on this idea of rationalizing the denominator. Now, the key when you are simplifying fractions involving roots is that you can never have a radical in the denominator. Now, the reason why is because, square root of 5, for example, is an irrational number. And when we're writing fractions, when we're writing rational numbers, you can't have an irrational in there. So what we have to do is we have to rationalize. And when we're doing this, what we're going to have to keep in mind is you have to keep the same value of the expression, but you need to get rid of the radical. Now, the way I like to explain rationalizing is to describe it as multiplying by a clever form of the number 1. And the reason why is you have to keep the same value. So the only way to keep the same value of a number when multiplying is to multiply by 1. But we have to be clever about how we're going to write the number 1. So if I have this example, 3 over square root of 5, 3 over radical 5, I'll notice right away I have a radical in the denominator, and I can't do that. So that tells me I need to rationalize. The way I'm going to rationalize is I'm going to multiply by a clever form of 1. The form of 1 that you use is, how do I get rid of a square root of 5? Well, that's to multiply it by another square root of 5. And the reason why is because the square root of 5 times the square root of 5 is the square root of 25. And, what is the square root of 25? Well, that's just the number 5. And so if I multiply the bottom by itself, by the radical that's in the bottom, it's just going to cancel out the radical, and I'm just going to be left with what's inside. But now I just changed the value because I just multiplied the bottom. But if I multiply the top by the same exact value, the square root of 5, I'm not changing the value. And the reason why is because any number divided by itself, doesn't matter if it's radicals, doesn't matter if it's irrational numbers, any number divided by itself will always be the number 1. So though I'm multiplying to us what looks like different values, it is actually the number 1. We are simplifying the expression. You can think of it as we are tricking the expression into getting rid of the radical by multiplying by a clever form of 1. So 3 times radical 5, 3 radical 5. So my answer is 3 radical 5 over 5. And so it doesn't even matter if it's a square root of x in the bottom, like in number 2, I have 5 over the square root of x. I would see right away I have a radical in the denominator, so I'm going to rationalize it. So I'm going to multiply the bottom by the same radical. And so I have to multiply the top by the same in order to trick the expression to think I'm actually multiplying by the number 1. And so I have 5 times the square root of x over x. Now I want to address one issue before we move on to the next couple of examples. And that is, well, why didn't we cross out the 5s? Why don't the 5s cancel? Or for example, why don't the x's cancel? And you need to remember that any number inside of the radical is protected. You cannot take a number on the outside and simplify with a number inside the radical. So whatever number's in the radical, you cannot simplify with a number on the outside. We only focus on the 3 and the 5. Can that be simplified? No. Same thing. This x is protected by this radical. We can't go inside and get it with a number from the outside. And so 5 over x cannot be simplified. So that's why we didn't bother to look at the simplifying of it, because it cannot be. I noticed that the 5 and the x are both protected, so they cannot be simplified with my 3 and 5 on the outside or my 5 and x on the outside. So let's look at the next two examples. Here we have 4 over 3 times the square root of 2. Now this one's a little bit different. What are we going to use to rationalize? Because I do have a radical 2 in the bottom. And so remember, when we rationalize, you multiply by a clever form of 1, but you use the part that matters. And if you think about it, the reason why you're rationalizing is because you have an irrational number in the bottom. You know, 3 is not irrational, but radical 2 is. And so what I'm going to do is I'm only going to multiply by radical 2 over radical 2, because I don't need to change this 3. It's already rational. I only need to change the ones that are not rational. And so multiply across the top, I get 4 times radical 2, so 4 radical 2. Now on the bottom, the radical is going to cancel. And so I'm going to get on the bottom 3 times 2, which 3 times 2 is 6. So right now I have 4 radical 2 over 6. We do need to be careful with our simplifying. Remember, this 2 is protected. However, the 4 and the 6 is just like the fraction 4/6. You know, how would you simplify the fraction 4/6? Well, they're both even. And so I would take out a 2 from both. And so I get 2 square root of 2 over 3 as my final simplified expression. And so we saw in this video that if you have a coefficient for the radical in the denominator, you don't care about the coefficient for rationalizing, because that is already rational. You only care about turning the irrational number into a rational one. And so if we examine number 4, we have the square root of x to the 4th over the square root of y cubed. The first thing I would do was I would take the square root of the top. The square root of x to the 4th is x squared. And then I would simplify the bottom. Because if I have the square root of y cubed, I can take one y out and leave 1 inside. And so here I just simplified. It's going to make it easier because I can notice now that my radical in the bottom is not square root of y cubed, it's just square root of y. And so I'm working with a smaller value. I'm going to rationalize by multiplying both the top and the bottom by just the square root of y. And so in the top, I get x squared, square root of y. And in the bottom, you get y times, and the square root of y times the square root of y is y. And so I get x squared, square root of y, over y squared. And that is my final simplified expression.